because this point P is a distance from our axis. Okay. And then as our axis rotates and this body rotates, this point P is going to trace out a circle. Something say like that. Now, if we measure from some arbitrary point along our axis, it could be up here, it could be down here, it doesn't really matter, but some arbitrary point along our axis, okay, measure from there to our point, okay, and our point is any point on this rigid body, doesn't matter where, okay, we'll give it this distance r, and r is going to form an angle with our axis here, call it phi. And if we think of it, okay, think of this as r, okay, and my hand is down here at this point here, and the end is up here at point P. Okay. Now, as point P goes around, because it's going to rotate, okay, as point P goes around, the length r doesn't change, and this angle here, phi, doesn't change. Okay. Now, the direction of r is going to change. It's going to be here, and then it's going to be here, and here, and here. Okay. But as P rotates around, the length of r stays constant, and this angle between r and this axis stays constant. So, r and phi are constant. Now, our point P is going around in a circle, and so we know the velocity direction of that particle is velocity. It's always going to be tangent to the circle, from what we've talked about many times. Okay, so our velocity is going to be, say, something like this. And I want to make that into a vector because it's the direction. Okay, and what I'm pointing, I'm not pointing up. Thinking 3 dimensions, that's going in the direction that's tangent to the circle at that point. Okay, so that's a tangent there. It's not perpendicular to this r. Kind of looks like it might be, but it's not. Okay. Now the distance from our axis to our point P as it travels in a circle, it's going to be a constant distance because it's a circle. And we'll just call that rho. So this distance here is rho. Okay. And our particle is going to travel around in a circle, say to this point right here on our circle. It's going to travel around in our circle to another point eventually out here, right? And that arc length of traveling around the circle, we're going to call that S. Okay. And the angle it sweeps out, as it's doing that, we'll call theta. The speed that our particle is traveling is the distance it travels, okay, divided by the time it takes to travel that distance. Right? And so it's going to be equal to ds, okay, s is our arc length, divided by dt. S is the arc length in the circle, so we know that S is equal to rho times theta, okay, where theta is measured in radians. So speed is equal to ds dt, as we just said. So this is equal to d of rho theta dt. Okay. But rho is going to be constant because it's just the radius of the circle is being traced out there. Okay. So this means our speed, not velocity, but our speed is equal to rho times theta dot. Okay, where theta dot is d theta dt. That we've done before. Now, let's look at rho for a minute. This is a triangle in here between this distance along here, r and rho. This is a right angle in here because the radius of the circle off of the axis is the center of the circle. Okay, so rho is equal to r times the sine of phi. So we said speed was equal to rho times theta dot, but I'm saying rho is equal to r times sine of phi, and therefore speed is equal to, what do I want to do? R sine of phi times theta dot. Yeah. Need to stop at this point because we really want to, but we have to stop. We're almost where we want to be. We're going to get into angular velocity and angular acceleration. So that's what we are going round. A couple of problems. Okay. The first one, 1285, obviously from chapter 12, dealing with space and stuff. Okay, so you should be able to do that. Okay. The next one I want to give you is 15.9. Okay. If you've taken physics and you've done angular velocity, angular acceleration, you'll be able to do that. If you haven't, we will finish this up on Monday and do an example dealing with this, so you'll be able to do it on Monday.
Do you have Monday off?
No, that's one more week. This day is a week from this Monday coming.
Okay, gotcha.
Yeah, so be here